Hello everybody, we are Team 3 and we have designed this programming language called Dolphin for the subject called 502, SER 502, which is Programming Language and Paradigms. Our team members are Abhinav Mohanty, Meenal Lad, Nikita Behel and Shubhangi Gupta. So in this presentation, we would like to cover about our programming language, the introduction to it, the features that are there in this programming language, the components in this language, the grammar, tokenizer, and the parser, along with the interpreter. Lastly, we will also show you a sample code and the execution for this programming language. Let's start with the introduction. So this language is mainly designed for beginners, and it is designed with the backend in Prolog, which is a logical programming language. The only data structure that exists in this programming language is a list data structure. We have used this list data structure to design symbol tables, which basically takes the type of the identifier that we're trying to store and also the value that is stored. For example, if we have an integer, so it'll store a value for integer z equal to 0. It is a very simple and fast programming language. Coming to the features, we have basically used this language to support digits starting from 0 to 9 and alphabets from A to Z. In this language, we also have this variable called z, which is mainly used to store the ultimate output of the entire program that we're trying to execute. For example, if we write a program to add two numbers, so the result will be stored in this z variable. The data types that are supported in this language are integers, characters, and a boolean. When we talk about the conditional constructs, we use if, then, else, if, then, and a ternary operator. For the operators that we support are the arithmetic operators, which includes the plus, minus, mod, multiplication, and division. And for the conditional operators, we have used these 6 operators. For the iterative constructs, we have written a code that will support a while loop, and we have also checked the type of the operations that are being performed. For example, if we want to add two numbers, we would make sure that the two numbers are of the same type, which includes, like for an integer, adding with an integer. So when we talk about the flow of the language, the code that we write, which is in the form of code1.dolphin, for example, the code is taken and passed to the main function. The main function calls the tokenizer. The tokenizer makes this entire code into a small list of tokens, which is passed to the parser. The parser takes these tokens and generates a parse tree. This parse tree is further passed on to the interpreter, which breaks down these nodes into smaller pieces and does all the operations on it. Lastly, the symbol table, which is a part of the interpreter, is used to store the runtime variables. For example, it stores the main intermediate values done during calculations. Our language basically has used context-free grammar. So the flow that happens here is the list of tokens that we get are basically passed in the form of a program. It will contain a main block. The main block further is divided into further set of statements. These set of statements will include a declaration. The declaration may consist of expressions or statements. The expressions that we have here could be arithmetic, Boolean, assignment, or a conditional statement. When we talk about the conditional statement, as we already said earlier, we do support ternary operators. For a Boolean expression, it could be in the form of just a true or false value, or it could be an arithmetic expression which we are trying to evaluate in the form of, for example, we are checking a equal to 2, where a is a variable and it would return a true or false value. The arithmetic expressions basically consist of all the arithmetic operations that we're trying to perform here, along with implementing the precedence. We all know about the BODMAS rules, which implements the division and the multiplication first, and then the addition and the subtraction. So the term, the factor, and the arithmetic expression together perform this operation. For the operators that we used in this language, which are mainly the conditional operators, are less than equal to, greater than equal to, not equal to, and the rest. For the commands, we have implemented the if, then, else, if, then, and a while loop. Lastly, the identifiers could be in the form of characters starting from A to Z, or in the form of digits, which is basically the numbers starting from 0 to 9. Next, I would like to ask Abhinav to explain you more about the tokenizer that we implemented for this language.
Hi, I'm Abhinav Manti. So I'm going to make you go through our tokenizer and the parser part of our programming language, that is Dolphin. So in our main file, you can see is first the tokenizer is called, which breaks down our whole program, which is typed into a text folder into a list of identifiers, keywords, and digits. So what the tokenizer does is basically takes the input from the file as streams and then sorts it into a list of atoms, and then differentiate each atoms into alphabets or numbers or tokens, and then passes it as a list into our parser. So as you can see, this is the code for our tokenizer. So where we first read the tokens from the file system and then pass it to our clean token space. What it basically does is removes the extra spaces that has been added into our program while typing it into the text file. And then what the clean token does is basically sorts each of the atoms into numbers and alphabets and generates the list, which is then passed on to our parser as an input in our main file, which is responsible for creation of the parse tree. So going back so to the tokenizer. So after the tokenizer part is done, so the input is the output of the tokenizer is taken as an input by the parser. So what the parser does is basically create the parse tree with the different nodes as different program block, the main block, and the Boolean expressions and various expressions, divides it into nodes. And we have used DCG to generate our parser program in Prolog. So as you can see here in our parser file, we are basically taking the input of the list of tokens and then creating the parse tree, which with various different nodes, including the declaration block, the command block, and the expression block, which is further differentiated into our Boolean expressions, and the type different data types as a separate node. And in the factor, we are basically differentiating each brackets, numbers, and identifiers, and whether it's a true or false, and then taking all the digit inputs and alphabet inputs from the list into the parser. And then the parser input is then fed into the interpreter, which is responsible for calculating the result of the program which has been input into the text file. So I think for the next section, it would be explained by my teammate Meenal Lad.
Hi, my name is Meenal, and today I will be explaining about working of our interpreter. Our interpreter takes parse tree as input from the parser and produces output after evaluating set of expressions. Throughout the whole program, we are maintaining two environments, our current environment and our final environment. Basically, our environment is a list of tuple which stores identifier, name of identifier, value of identifier, and data type of identifier. We are generating the initial environment in the form of symbol table. We have two main functions in our interpreter, lookup and update. In our lookup function, we are basically looking up the value of an identifier in our current environment. And in our update function, we are updating the value of identifier in our current environment. We have implemented basic features such as if else, if then else, while loop, and ternary operator. In our conditional constructs, we are initially checking the Boolean expressions. If the Boolean expressions returns true and false, according to that, we are evaluating set of expressions for all the conditional constructs such as if else, if then else, and ternary operator. In our while loop, we are basically recursively calling the eval while loop rule and updating the identifier in the current environment. And finally, we are updating the final value of the identifier in our final environment and passing it back to generate the output. We have also restricted the expressions to be the data type of the identifiers to be integers. We are checking the type of the data identifiers. We are making sure that no two different data types perform expression evaluations, such as integer, boolean, or boolean character. It should be strictly integer. So basically, we have implemented the logic of type checking in our interpreter. So our next sample code demos will be given by my teammate Shubhangi Gupta. Thank you.
Hello, my name is Shubhangi and I'm going to show you sample execution of the following code for our programming language. So here are a few things what I want to point out. First, that you should be in the current working directory where the main program is there, and for our case, here it is in the source folder. So I have basically copied all the programs in that folder so that we can directly access it. So here, so how I will show you how to load a main program in the execution environment. So here it is done. So our so our main file name is main underscore dolphin.pl. So here it is loaded. Now here you can pass your code as an argument to the main program and it will execute it. So here if you see, so it is the file name and the second argument is the parse tree. Basically it is not an argument, it is a variable that will store the intermediate code of our language, and the third will be the result, which will store the result. So if you can see, so I ran the code 1, which is basically a code that contains a while loop inside if then else condition. So here it is executing perfectly. And the intermediate code that is generated can be seen in the screen, and I'm going to show you a few more codes. So let's just say here, so here is one more thing where this program contains if then else statement within a while loop, so it also executes perfectly, and we'll see the intermediate code as well as the result of this code. So that file was code 5.dolphin, and if you execute it, here you can see that parse tree and the result are generated perfectly. So one more thing I wanted to point out, like for our program, all the outputs are stored in the variable z. So there is no other variable that will store the result. So in every program, if you want to store a result, that will be in z itself. So and also here is one important thing. Since we are doing the type checking, here like in this program we can say that y is integer type and u is boolean type, and when we are trying to add these two variables, it should throw an exception. So let's execute it. So that file was code 7.dolphin. So when we are executing it, it is throwing an exception like this, if you can see this. So type misprint needs integer for expression evaluation. So that is a good thing about our language, and the result is 0 because nothing has been calculated or evaluated. So these were the sample programs, and thanks for watching it. Thank you.